Hello. When comfortably settled in your favorite chair, watching the unusual video of our project, sometimes it seems like the world around you has frozen. Your mind is convinced that you are standing still, while in reality, you are hurtling through the vast universe. This is because your brain measures speed relative to nearby walls and objects, creating an illusion of immobility. However, reality strongly reminds us of its dynamics. First, realize that you are on the surface of the Earth, which is rotating around its axis, causing you to make immense circular movements every 24 hours. The Earth, in turn, moves around the Sun, and the Sun revolves around the center of the Milky Way. The latter is also in motion, traveling as part of the local group of galaxies towards the Great Attractor, a massive gravitational point. This complex system of movements ensures our journey through the universe at an impressive speed. Everything is relative. Let's repeat it once again. All speeds are relative. In other words, we can measure the movement of an object only relative to another. The absolute speed of an object remains unknown to us because determining it would require information about a stationary point in the universe, which, in reality, does not exist. So, the answer to the question of how fast we are flying through the universe is quite simple. We don't know the absolute speed of our movement. However, we can calculate relative speeds, and to embark on an exciting journey through the universe, it's enough to choose a good starting point. I suggest starting with your favorite chair at home. Get ready for an exhilarating journey because it has already begun. Let's start by looking around. Compared to the walls and objects surrounding us, our chair and we seem motionless. Thus, our initial speed is considered zero. Speed relative to the Earth's axis. We are somewhere on the Earth's surface, which is rotating around its axis. If our home were located at the pole, our movement would be limited to a slow rotation around its axis, taking 24 hours. However, the farther our location from the poles, the greater the distance we cover around the axis of Earth's rotation. Let's bring a few examples. A resident of Ushuaia, the southernmost city in Argentina, describes a circle with a radius of about 3,700 kilometers around the Earth's axis at a speed of 962 kilometers per hour every day. While a resident of Punta Arenas, Chile, slightly to the north, moves at a speed of 1,000 kilometers per hour. However, those living in Vladivostok, Russia, describe an even larger circle and move at a speed of about 1,200 kilometers per hour. In short, those who describe the largest circle in 24 hours move faster. They are the ones closer to the equator. So, if you're currently in Quito, the capital of Ecuador, hold on tight to your chair, because it is moving at a speed exceeding 1,670 kilometers per hour, faster than sound. Speed relative to the Sun. The Earth moves around the Sun, describing an orbit with a radius of 150 million kilometers. The speed along this orbit is 107,208 kilometers per hour, which is 87 times the speed of sound. If we add the Earth's rotational movement at the moment, we get our total speed relative to the Sun. Speed of the Sun around the center of the Milky Way. The Sun is just one of the hundreds of billions of stars making a journey around the center of our galaxy, the Milky Way. The dimensions of the Milky Way are so immense that conventional units of measurement are unable to convey its scale. For a better understanding, let's recall that the radius of the Sun's orbit around the galactic center, expressed in kilometers. This is such an impressive magnitude that astronomers had to use a new unit of measurement, the light year, to avoid an enormous number of zeros. A light year is the distance light travels in 1 year. Even with this unit, we encounter a vast number. The distance from the Sun to the center of the Milky Way is 25,000 light-years. Thus, the Sun moves around the galactic center, describing a massive orbit at a speed of 792,000 kilometers per hour, which is equal to 220 kilometers per second. At this speed, one could orbit the Earth quickly in 3 minutes. Speed in the local group. The Milky Way is part of a group of galaxies known as the local group. This cluster comprises a total of 30 galaxies, with 2 prominent ones being our Milky Way and the Andromeda Galaxy. Objects in this group are moving towards each other at a speed of 468,000 kilometers per hour, which is 130 kilometers per second. If this motion persists, the galaxies will collide in the distant future, approximately 5 billion years from now. Speed of movement toward the Great Attractor. The local group of galaxies is part of a larger structure known as the Virgo supercluster. However, measuring its movement initially presented significant challenges. In the past, the universe was considered homogeneous, making it impossible to determine the direction and speed of our group of galaxies in any particular direction. However, with the advent of new powerful tools, scientists have been able to measure the relative velocities of a vast number of galaxies and unexpectedly discovered that the universe is far from homogeneous. It turns out that no less than several million galaxies, relatively close to the Milky Way, are moving as a single entity in a specific direction through space. In 1987, a group of 7 astronomers measured the coordinated movement of several million galaxies around us. Scientists concluded that all these galaxies, including the Milky Way, are moving at a significant speed, 600 kilometers per second. Apparently, the cause of this rapid movement is the gravitational force emanating from an extensive region of space known as the Great Attractor. In conclusion, it is worth noting that determining the specific value of our overall speed through the universe is challenging. This is because the considered speeds point in different directions, and, therefore, they interact with each other. It depends on the specific moment in time in which we are moving. I don't know about you, dear friends, but such speeds make my head spin.